Hey, what's up guys? In this video we're going to take some derivatives of, like, as you can see, of the sine of x, the cosine of x, the tangent of x, the natural exponential of x, and the natural logarithm of x. Before we get started, I've drawn a unit circle here to show you what we're talking about. Okay, now let us take this first derivative. It is a derivative of sine, so you can write it the derivative dx of you can put it like that, of the sine of x. Okay, or you can even write it the sine prime. All right, so as you can see here, we're talking about a sine, and this sign is positive, so we're talking about this sign here. When you derive it, you go to the cosine, so a result will be the cosine of x. Okay, the second derivative will be derivative of the cosine, so we're writing the cosine of x. Also, we can write it the cosine prime of x. Okay, and where we're at here, the cosine positive, so the derivative is the sine negative. And now we take the derivative of the tangent. Okay, oh sorry, derivative of the tangent. First I have to write tangent here. Of x. Alright, as you know, the tangent is the sine divided by the cosine, and it is positive. It means that the derivative, the tangent is something like this, running on a unit circle. Hold on, take a different color. It's something like this. It goes that way, something like this, and something like that. That's a tangent. For example, not that good, but yeah, that's a tangent, and we have a sign positive. So we can also write it is here. If you want to do that, you can say that it is, because we said we can even write the sine prime. We can say that it is a sine prime of x divided by the cosine of x. Both prime, because we're deriving both. Okay, and you know that the derivative of sine is cosine. Here we can use the quotient rule to work this out. Okay, and the quotient rule stipulate, we can write it here, the quotient rule stipulate that when you have u, I'll take a different color here, when you got u divided by v prime, both you're getting bright, it's gonna give you u prime times v minus u v prime divided by v to the power 2. Okay, so let's assume that u is v here. The sine is u here. So the derivative of the sine, that's what we said here. Okay, derivative of sine is cosine, so we're going to put cosine of x times v, which is also cosine of x, minus the derivative of the cosine is minus sine. We put a parenthesis, is minus sine of x. Okay, times u. Okay, it is also the sine of x, and the whole thing divided by the cosine to the power of 2 of x. Okay, so now we're going to say that as you can see here, the cosine times the cosine gives us the cosine to the power 2 of x, and here the minus is applying in here, the parenthesis. It's going to give us minus times minus is plus. We have plus, and sine times sine gives us the sine to the power of 2x, the whole thing divided by the cosine to the power 2 of x. But we also know that according to the trigonometry identity, we also know that the cosine, we also know that the cosine to the power of 2x plus the sine to the power of 2 of x equals 1, or you can even write it the sign to the power 2x. Okay, so that's going to give us here 1 divided by the cosine to the power 2 of x. Okay, and 1 over the cosine to the power 2 of x is the secant squared of x. Okay, okay, and now we will take the derivative of an exponential, right? E to the x. Okay, we're gonna write e to the x, right? I mean derivative dx of e to the x. We can write like this. Okay. Um, and this derivative is equal to e to the x again. All right. So let me just show you how it happened. Okay. So we know that the e function equal to ex is the inverse function of y equal to natural log of x. This is an inverse. Okay. So this is what we can do. We can say that we said y equals to e to the x, right? This one means what we got here, right? The log of x, the log of y equal to x. So this is inverse. Okay. So by doing what? So we wrote the log, natural log in here, natural log in here, natural log in here, and natural log of e to the x is x, and then we have the natural log, right? Now we're going to take the derivative of both sides with respect to x, okay, and then apply the chain rule to the log. By doing this, we will have here the derivative. We will have 1 over y, and because it's derivative, y prime equals to 1. Okay, and that means here we're going to see that y prime equals to y. Okay, and this is exactly what means that the derivative dx of e to the x equals to ex. Alright, and the derivative of the last one of log, natural log, and the derivative of natural log of x as an inverse function of e to the x is going to be 1 over x. That's what we're going to see in our next video. Okay, so thank you for watching, guys. Again, until next time. Bye-bye.